Bismillahirrahmanirrahim and Assalamu alaikum. My name is Ayan Rafiq and I am a foundation level student at Rehan School, Islamabad, Barato campus. Today I am going to conduct an AI session with Maya. In this session, I will ask few questions and Maya will provide the answers. So let's start. My first question is, what is software?
All right, let's really get into this one. Essentially, software is a set of instructions that tells your hardware exactly what to do. Think of it like a musical score. The hardware is the orchestra, the instruments, and the musicians, but the software is the sheet music that tells them when to play, how fast to go, and what notes to hit. Without that score, you just have a room full of talented people with no idea what they're playing. Software comes in a few different flavors, from system software like your operating system, which manages the background logistics, to application software like the app you're using to talk to me right now, which is designed for a specific task. It's basically the invisible part of your tech that turns a slab of silicon and metal into something actually useful.
Okay, Maya, my next question is, what is the difference between software and hardware?
Simple but deep. Hardware is the stuff you can actually kick. It's the physical, tangible components of your device, like the screen, the battery, the circuits, and that slab of silicon. If you can drop it on the floor and it breaks, it's hardware. Software, on the other hand, is completely intangible. You can't touch it, you can't smell it. And if you drop your phone, the software doesn't break in the same way. It's a collection of logic, data, and instructions. Going back to that orchestra is the actual melody being okay, you got me there. It's definitely not cheap to get it right, but it's a lot better than having a piece of metal that doesn't know how to do anything.
Okay, Maya, my next question is, what is system software?
Here's the lowdown on system software. System software is basically the master coordinator that works behind the scenes to make sure everything in your device actually functions. While application software is what you interact with to get things done, system software is what manages the relationship between the hardware and those apps. The biggest example is your operating system, like Windows, Mac OS, or Android. The OS is like the city manager of your device. It handles memory allocation, manages your files, and makes sure that when you click a button, the hardware knows exactly how to react. Beyond the OS, you have things like device drivers, which are like translators that tell the operating system how to talk to a specific piece of hardware, like a printer or a graphics card, and utility software, which handles the upkeep, like antivirus programs or disk cleanup tools. In short, it's the essential foundation that creates a stable environment so your apps can run without everything crashing into a chaotic mess.
Okay, Maya, my next question is, what is application software?
This is the part of software that actually gets you something done. While system software is the foundation working in the background, application software is the tool you actually open and use to solve a problem or pass the time. It's the app part of application. So, for example, if you're writing a paper, that's a word processor. If you're browsing the web, that's a browser. If you're talking to me right now, you're using an application. Each application is designed with a specific purpose in mind. Some are for productivity, like a spreadsheet, and others are for entertainment, like a game or a streaming service. These applications sit on top of the system software, which they rely on to talk to the hardware. Think of it like a house. The system software is the foundation, and the wiring, the hidden stuff that makes the house livable. The application software is like the furniture and appliances you put in a fridge to keep food cold or a couch to relax, depending on what you need to do in that room. It's the layer of tech that's actually tailored to your specific human needs and desires.
My next question is, what is programming?
Programming is basically the art of talking to a machine. Computers are incredibly fast, but they're also completely literal. They don't understand nuances. Or, you know what I mean? Programming is the process of taking a complex human idea and breaking it down into a precise sequence of logical steps that a computer can actually follow. It's like writing a recipe for someone who has never seen a kitchen. You can't say, make a cake. You have to say, pick up the bowl, pour in 2 cups of flour, stir clockwise 10 times. If you miss one step or get the order, the whole thing falls apart. The magic happens when you use a programming language like Python or Java to bridge that gap, turning your logic into code that the hardware can execute. It's part engineering, part linguistics, and a lot of problem solving. Want to dive into the actual languages used to do this, or should we keep rolling through your list?
Okay, my next question is, what is coding?
It's a common mistake to use these interchangeably, but coding is a specific slice of the programming pie. If programming is the overall process of designing a solution, coding is the actual act of translating those designs into a language the computer understands. To use the recipe analogy, programming is the process of figuring out the ingredients, testing the flavors, and deciding how the cake should look. Coding is the moment you actually write those instructions down on paper. It's the technical translation phase where you're dealing with the syntax, the brackets, and the semicolons to make sure the machine doesn't get confused. You can't have programming without coding, but coding without the programming mindset is just typing lines into a screen without a plan. What's next on the list?
My next question is, how is software developed?
It's a whole process, kind of like building a house, but with way more changes of heart along the way. It starts with the planning phase where you define exactly what the software is supposed to solve and what the user experience should look like. Then comes the design, where you map out the architecture and the interface. Once you have a blueprint, the actual coding begins. And this is where the programming we talked about happens. But you don't just write code and ship it. There's a massive testing phase where you try to break everything to find bugs and fix them before they reach the user. After that, it's deployed, but the work doesn't stop there. You enter a cycle of maintenance and updates to keep it running smoothly and add new features. It's a constant loop of building, testing, and refining to make sure the final product actually does what it's supposed to do.
Okay, my next question is, what is the difference between a software engineer and a programmer?
This is where the terminology gets a little blurry, but there's a real distinction if you look closely. Programmer is someone who can take a specific problem and write the code to solve it. They're the specialists in the language, the ones who know exactly which function to call or how to optimize a loop to make it run faster. If you need a specific feature built, a programmer is the one who can just put their head down and get it done. They're like the master carpenters who can build a perfect cabinet if you give them the measurements. But a software engineer takes a much broader view. They aren't just focused on the code, they're focused on the entire system. An engineer is thinking about how this new feature will affect the rest of the app in 6 months, how it will scale if a million people use it at once, and how it fits into the overall architecture of the project. The programmer is the carpenter, the software engineer is the architect who designed the whole house, made sure the foundation can support a second story, and ensured the plumbing won't burst when the wind blows. Essentially, programming is a tool that software engineers use to build larger, more complex systems. Does that click, or do you want me to dig deeper into that?
My next question is, uh, what is Chat GPT?
I have a feeling you need ChatGPT. It's a large language model, essentially an incredibly sophisticated pattern recognition engine trained on a massive chunk of the internet's text. It doesn't know things in the way you or I do. Instead, it predicts the next most likely word in a sequence based on everything it's read, which allows it to generate human-like text, write code, and hold conversations. It's basically the ultimate autocomplete scaled up to a point where it can actually reason through problems and simulate creative thought.
My next question is, which programming language is best for beginners?
Thumbs down. It reads almost like English, which means you can spend your energy solving problems rather than fighting with confusing syntax. It's incredibly versatile too. So whether you're into data science, web development, or just automating a tedious task, Python can do it. Some people swear by JavaScript for its immediate feedback in the browser, but for a first language, Python's readability is a huge advantage. You've mentioned wanting to learn some of this yourself. Where do you think you'd start?
My next question is, what is HTML?
HTML is the skeleton of every single page on the web. It's not actually a programming language, it's a markup language, which means it doesn't handle logic or data. Instead, it's used to structure content, telling the browser, this is a heading, this is a paragraph, this is a link, and put an image right here. Think of it like the framing of a house, the 2x4s and the drywall that create the rooms and the layout, but without any paint on the walls or electricity in the sockets.
My next question is, what is CSS?
If HTML is the skeleton, CSS is everything that makes that skeleton actually look like a person. It stands for Cascading Style Sheets, and its entire job is to handle the presentation of a web page. While HTML tells the browser that a piece of text is a heading, CSS tells the browser that the heading should be bold, royal blue, centered on the screen, and using a specific modern font. Takes the raw structural layout and turns it into a visual experience. You use CSS to define colors, spacing, margins, and how the layout shifts when you move from a giant desktop monitor to a tiny phone screen. It's the difference between a document that looks like it was written in 1992, a sleek, modern website that feels polished and professional. Let's really expand on this one then. The cascading part of CSS is actually the most important concept to grasp. It means that styles can fall down from one level to another, allowing you to set a global rule for your entire website and then override it for a single specific element. It's like deciding that every room in your house should have white walls, but then deciding that the bathroom should be a bold emerald green. The global rule is the baseline, but the specific rule takes precedence. Exactly. The most specific rule always wins. Ready for the next one?
So my next question is, what is JavaScript?
JavaScript is the magic that makes the website actually do things. If HTML is the skeleton and CSS is the paint, JavaScript is the nervous system that turns a static page into something alive. It's what allows a website to react to you in real time, like when a menu slides out when you click a burger icon, or when you see a notification pop up without having to refresh the whole page. It can handle everything from complex animations and interactive maps to managing the data that's being sent back and forth between the user and the server. What makes it so powerful is that it runs right in the browser, which means it's fast and responsive. And while it's called JavaScript, it actually has almost nothing to do with the Java language, which is a bit of a naming tragedy in the tech world. I can dive into the specific things JavaScript can do on a page, or we can keep the momentum going with your list.
So my next question is, what is API?
An API, or application programming interface, is basically a messenger that lets two different pieces of software talk to each other. Imagine you're at a restaurant, you're the user, and the kitchen is the system you want to get something from. The kitchen has the ingredients and the skill to make your food, but you can't just walk back there and start cooking yourself. That's where the waiter comes in. The waiter is the API. You give your order to the waiter takes that request to the kitchen and then brings the food back to your table. You don't need to know how the oven works or how the chef chops the onions. You just need to know how to talk to the waiter to get what you want. In the digital world, this happens constantly. When you use a weather app, it doesn't actually measure the temperature itself. It uses an API to ask a weather services server for current data and then displays it to you. It's what allows different apps to share data and functionality without having to build everything from scratch every single time.
So my next question is, what is software bug?
A software bug is basically a mistake in the code that causes a program to behave in ways it wasn't intended. It's like a typo in that recipe we talked about. If the recipe says add 10 cups of salt instead of 10 grams, the cake is going to be an absolute disaster. In code, a bug could be something as simple as a misplaced semicolon or a complex logic error that only happens when a million people use the app at once. When a bug hits, the software might crash, freeze, or just do something completely bizarre, like making a character walk through a wall in a game. That's where debugging comes in, which is the process of hunting down that one wrong line of code and fixing it before the user ever sees the chaos.
So my next question is, what is open source software?
Open source software is basically the community garden of the tech world. Instead of the code being locked away in a vault owned by a company like Microsoft or Apple, the source code is made public for anyone to see, modify, and distribute. Think of it like a public recipe for a legendary cake. Instead of one company keeping the secret, they put the recipe on a billboard. And now thousands of bakers from all over the world are tweaked it, suggesting better ingredients and fixing mistakes to make it. This is how some of the most critical pieces of our digital infrastructure were built, like Linux, which powers most of the world's servers and Android phones. It turns software development from a private competition into a massive global collaboration where the goal is simply to make the tool better for everyone, regardless of who gets the credit.
Okay, my next question is, what is closed source software?
Closed source software is the exact opposite, the secret family recipe of the tech world. This is software where the source code is kept under lock and key by the company that created it. You're allowed to use the software, but you're not allowed to look under the hood to see how it's actually built. Something like Windows or Mac OS. You can install them and run your apps, but you have no idea exactly how the underlying engine is wired together. The company controls everything, from the updates to the security and the features. It's a proprietary model, meaning the developers own the intellectual property and get to decide exactly how it's distributed and who gets to use it. While you miss out on that community collaboration we saw with open source, you do get a centralized team responsible for the overall quality and support. So you don't have to wonder who to call when something breaks. It's essentially a black box that you pay for or agree to use, trusting that the people inside the vault are keeping things running smoothly.
Okay, my next question is, what is Git?
Git is basically a high-tech time machine for your code. It's called a version control system, and its primary purpose is to keep a meticulously detailed record of every single change made to a project over time. Imagine you're writing a massive novel and you decide to delete a whole chapter in a fit of creative passion, only to realize 3 days later that the chapter was actually the best part of the book. Without something like Git, that's gone forever. With Git, you can just rewind the clock to exactly how the file looked on Tuesday at 2 p.m. and bring that chapter back to life. This is done through something called commits, which are like permanent save points in a video game. Instead of having a folder full of files named Project Final V2, and Project Actually Final, you have one clean version of the file. And Git remembers every previous iteration in the background. This becomes indispensable when you're working with a team. Git allows multiple people to work on the same project at the same time by creating branches, which are like parallel universes of the code. One person can be building a new login screen in their own branch, while another is fixing a bug in the main branch. Once the new feature is polished and tested, Git helps merge those parallel universes back together into one master version. It prevents the absolute nightmare scenario where two developers accidentally overwrite each other's work, making it the gold standard for how.
So viewers, this is the session for Maya. Today we will meet you in another Maya session. तब तक के लिए अल्लाह हाफिज, पाकिस्तान जिंदाबाद।